So the last video here, the last example in this section is about what we call solving the right triangle. That's a phrase that essentially just means find all of the possible missing values. So given, in this case, some pieces of information, in this case, we're given 2 of the side lengths, but you could kind of do this from some of the earlier examples as well, right, where we had kind of one of the angles and one of the sides. There's a number of sort of different approaches here. Solving the right triangle just means find all of the missing information. So in this case, we need to find, right, the third side, the missing side length. We're also going to need to find the 2 angle values, A and B. We know angle C is 90 degrees. That's kind of always a given. We've got 2 of the 3 sides. So a number of different ways to start. I think maybe the most obvious thing here would be find that third side, right? Because we can do that with our Pythagorean theorem. We've sort of reverted back to our ABC triangle setups. So the Pythagorean theorem is kind of sitting right there for us to use. In this case, our 2 legs, right, are 5 and 12. So the 5 is the A value, 12 is the B value. So if we start to sub this in, right, A squared, 5 squared, 25, B squared, 12 squared, 144. 25 plus 144 would be 169, and maybe not super obvious, but if you take the root of that, you're going to get 13. So the third side here, our hypotenuse, our long side, is going to be 13 inches. So we can kind of redraw this triangle. And what we can do from there is essentially just pick either of the, you're kind of going to pick either of the angles, A or B, to use as sort of a perspective angle. We'll just use A for alphabetical sake, I guess, more than anything else. So if we let A be our theta, A be our perspective angle, that kind of then defines, right, 13 is the hypotenuse, as always, but it associates the opposite side with the value 5 and the adjacent with our 12. What we're going to do here is the same thing we were doing in the last video. We need to do some inverse trig work to be able to find one of these angle values. So we have a lot of flexibility here. In theory, we know all 3 sides, so we can just sort of pick whichever one of the trig functions is our favorite. I guess we're going to use sine in this case because it comes first. So the sine inverse of the opposite over the hypotenuse. That would be 5 over 13 in this case. And if we crunch that number in our calculator, it turns out the angle there is going to be 22.6 degrees. The nice thing about this is, well, if I know one of the corner angles, in theory, you could set up another picture, sort of use B as your perspective angle and do a whole nother round of trig inverse work. But you don't really need to, because if you know the 90-degree angle in the corner, which we do, and then you know the other, one of the 2 corner angles, A, is 22.6, you know all 3 of them should add to 180. So if you sort of just set up 22.6 plus the missing one, B, plus 90 is 180, it's really just a hop, skip, and a jump, right? So to add them up and subtract, and you're going to be able to sort of find that your third angle would be 67.4. So you really only need to do the inverse once. If you find one of the corner angles, you can always just do a pretty quick addition setup, right? You knowing that they're all going to add to 180, or you could sort of even shorthand that and say the 2 corners would add to 90 because you already have 90 degrees taken care of with your right angle. And that'll get you there. If we jump to the exercises, again, you guys are doing the odds here. So I'm going to do number 20. You can see all these were giving you sort of 2 of the 3 sides. The one thing that's different here in the example we just did, we gave you sort of the 2 legs, A and B. In this case, we've got the hypotenuse in one of the legs. So that changes our setup just a little bit. But as you can imagine, it's not going to be too different from what we were just doing. So here's our picture, right? ABC, angles ABC. We know angle C is 90. We know side B is 3. We know side C is 5. So it's Pythagorean theorem to find this missing side length A, one of the legs. So subbing in our 3 and our 5, we're going to get squared is 9 and 25. If we subtract the 9 over, that means A squared is 16. And so obviously taking a root, that means that the A value here is going to be 4, right? So that's just our regular Pythagorean theorem stuff from back a couple scales at the beginning of the trig section. From there, right, we know that angle C is 90 degrees, so we need to pick either A or B. And we're going to use the inverse trig to find it. I'm going to do B here just for a change of pace. We did A in the last one, so why not do B? Let every angle have a turn. So B is sort of in the upper corner. That means, right, from the B perspective, side length 3 is the opposite, side length 4 is the adjacent, and 5, of course, as always, is the hypotenuse. So we can set up, again, sort of with any trig function we want. I did cosine here again, just to kind of mix it up. We did sine in the last one, but really it's your choice. You could go tangent if you wanted to. Either one of those will do. So the cosine for this angle, right, would be the adjacent over the hypotenuse, would be 4 over 5, right, from that perspective, from the B perspective. 4 over 5 would be 0.8. So that means for us, the angle value should be the inverse of 0.8, right? So take your fraction and divide it, get a decimal there. Some calculators, right, you're going to get into trouble if you try to calculate cosine inverse of 4 over 5. They're going to do cosine inverse of 4, and then they're going to tell you that's an error, just for the order of operations. So always watch that. I would just divide first, get a decimal, and then use your decimal here. So if we use the 0.8, we do cosine inverse, right, from the degrees perspective, we should end up at about 36.9. Now, do we need to do another sort of inverse trig setup? And the answer, of course, is no. I know 2 of the 3 angles, and they should all add to 180, right? So 36.9, the C value is 90. A plus B plus C is 180. So if we add these guys up and we subtract it away, the A value here, our final angle, should be 53.1. So we've got all 3 of the angles here. We knew from the beginning, right, the side lengths B and C, so the only side we were missing was side A, which is there. So we got all 3 sides, all 3 angles, and that's the idea. This triangle has been solved.